All right. So once again, talking about two people on pool donuts interacting with each other. And we want to predict the outcomes, and that's going to be based on how much mass each person has. So let's try to talk through a couple situations. First, let's have let's do that. Let's have the more massive person coming towards the less massive person. Now, by the time they actually get there, we have to remember that mass goes hand in hand with inertia. The more mass, the more inertia. The more inertia, the less change. Okay, so the massive person comes in, and I go to push my niece's donut. Because she's significantly less massive, less mass, less inertia gives her more change. So as I'm pushing on her, she changes faster than mine. Her velocity changes faster than mine. We still have the same amount of momentum exchange, right? I gave her 6 kilogram meters per second of momentum, but she's gonna change her velocity by more because she has less mass. Take a second and process that. We're gonna have the same momentum change, but she's gonna change velocity by more because she has less mass. And the result of that is that she flies away from gaining all that extra velocity. Now let's do the opposite. Let's imagine I was stationary and she's coming towards me. I have more mass and I'm going to change my velocity by less. The result is that she's pushing. She might run out of speed and I still haven't moved yet. Well, I've moved a little bit. So she keeps pushing. And she's gonna end up U-turning by the time I start moving that direction, all right? So when you have a low mass object hit a high mass object, the low mass object hits and changes direction. When you have a high mass object come and hit a low mass object, it'll power through. It'll speed this one up and it itself will continue going. If I have just the two of them next to each other, and neither of them are moving, and they push off each other, the high mass, big mass will have a slow speed, and the small mass will have a big speed. In both cases, they change their momentum by the same amount, right? Maybe the total amount of momentum gained here is 12 kilogram meters per second, right? These are going to be unrealistic numbers. But here, it was accomplished by having a mass of 6 and a velocity of 2, while here, and that's actually to the left, so it's negative 2 meters per second and negative 12. And here, maybe that was accomplished by having a mass of 1 and a speed of 12 meters per second. Still, we have the result of 12 kilogram meters per second. She gained 12, I gained negative 12. But the overall result is still true, that my P initial total equals my P final total. What was my P initial total? Initially, I was at 0 plus 0. And then at the end, I was at negative 12 and positive 12. So that still ends up being true. The total momentum gained by one is lost or gained negatively by the other.